Hey, I have a second channel. Cube Compium TDX. Hey everybody. So here we have the Internet Explorer PC plugged into power and Ethernet. It's just sitting here shut off. Power's on though. The power supply is actually on. You can see right there this little Ethernet activity indicator, so the LAN controller is active. Now watch this. I'm going to kill power to the power supply and watch how long it takes for this Ethernet controller to shut off. That was not even a second. So yeah, not very long at all. Okay, so the power supply that's in the IEPC is this, I guess we can call it this rebuilt unit that I refurbished some time ago. It was originally a pretty cheap end, included with case special. It was originally branded as Kohler's IT, and it was their supposedly 480 watt model. I've totally recased it into a different PSU case because the original case was absolute garbage. And if you can see through the back here, let me readjust the camera. You may be able to see how I have beefed up things a little bit inside this unit. If it would actually focus on what's inside, you can see a couple of common mode chokes in there. The power supply originally did not have those. There's also a bridge rectifier in there, which it originally didn't have. We've also got X caps that originally didn't have. It's got a Y capacitor on the AC plug, which the original unit did not have. We're going to open this thing up here in a moment, but first let's go and head over to our table. So here I got some primary caps laid out here on the table. So I got them, of course, sectioned into two groups, and I've also got some caps still in here as well. But never mind these. But you can see over here we have these capacitors over here and these over here. These over here are ones that tested near their rated capacitance in microfarads. So this one right here, this Unite brand capacitor, which is kind of an off-brand, 470 microfarad, 200 volts. It actually did measure about 470. Here we got a Capson 560 microfarad. It measured right about 560. Another Capson 470 microfarad. This one measured in the ballpark of 470 microfarads. We got this Phi, if we want to call it that, capacitor brand. While I can say it measured pretty close to 1200, it was actually right about 1000. I'm going to say that these caps actually kind of belong over here on this pile over here, but I'm going to set them in the back. I'll explain why in a moment. So, we've got this Elite capacitor here, 560 microfarad. It actually measured pretty close to that. Alright, so you kind of get the idea with these caps. These capacitors here were pulled from decent units that I scrapped for whatever reason. Let's say something failed with them. Like these slim Capsons, almost all of them were pulled out of Bestech ATX 250-12E power supplies. You know, the infamous E-Machines motherboard killer. But we come over here to this other group of capacitors here. And you can see these are some lovely off-brands right here. We've got these full tacks. We've got these, well, no brands here. We've got the Yang Chuns, which these came out of a Allied or Deere unit. We've got these Jun Fus here, which came out of an Allied or Deere unit. We got these Gen Cons, which came out of an Allied or Deere unit. We got these MK caps, which came out of a Kohler's IT unit. And the full tech back here, I think I may have mentioned already, came out of a Kohler's IT unit. The one thing that all of these capacitors have in common is each and every one of these caps Let's say it's a 470 microfarad capacitor, or at least that's what it says on the label, 470 microfarad. It actually measured in at 330 microfarads, which is I'd say it's one step lower than the 470. In power supplies, you would have like 470, you'd have 330, you'd have 220. Now, keep in mind, 330 microfarad caps, that's typically what you would find in a 200 watt power supply. 250 watt power supplies would have 470 or 560 microfarads. 300 watt supplies would have between 470 to 680, sometimes more than that. These phi's back here, I want to say, like I mentioned, they measured right about 1,000 or more. The meter I use to measure these caps out at 1,000, so the meter did actually go into out of range. So these are measuring between 1,000 to 1,200 microfarads. So of course, the step below 1,200, I believe would be 1,000 microfarads. So these caps actually came out of a Roswell, I want to say 650 watt unit that had its primary switchers blow. Actually blew the fuse. It was a power supply that was brought to me by a former classmate in college. I think I may have a video of this unit up on the channel, and it's from years back. I'll have to go look, and if it's there, I'll note it up here in the corner. That way you can go back and watch it. But let me go ahead and grab this meter here, which is got this nice Klein Tools multimeter that I brought for it, because it has a capacitance function, and I brought it home just for the weekend to try to see how it does with measuring capacitors, and I've learned that it can only measure up to 1,000 microfarads, which, for these big guys, it's alright. But I am looking into getting a different capacitance meter, that way I can measure bigger caps, like, let's say 1,500 or 2,000 microfarads or more, or 2,200, excuse me. But set the capacitance, and I got to set the camera up here on the table for this. Okay, so I'll try to put this in view of the screen, or the video. You see right now we're measuring pretty much nothing because we ain't got really anything hooked up. So let me start out with this 470 microfarad Capzon. Now this capacitor here is probably about 10 years old. Again, it came out of a Bestech ATX 250-12E power supply. So I'll go ahead and measure it. .484. So yeah, 487, 490 roughly. So it's definitely within tolerance and not bad for a cap this age. Now, of course, the cap could have some ESR or series resistance, but I'd say it would be a good candidate to drop into a power supply if needed. That's kind of why I saved these. Let me choose a different capacitor over here. Let's go for this Chemicon 470 microfarad, and of course, gotta make sure that we hook these leads up correct because these caps are polarized, and it takes a moment for the get the capacitance. 497. So yeah, almost 500. How about this OST 560 microfarad? That one's a little lower than spec, but still, that's, I guess that's not terrible. 536, 540. Now, I don't know the exact percentage of tolerance these have, but anyways, you kind of get the idea. These caps over here are a bit more reputable. They came out of more decent power supplies. They're much closer to being within spec, or most of them are in spec. I'd say they're within their tolerance, most of them anyway. Now, let's choose this GenCon capacitor rated for 470 microfarads at up to 200 volts. So we're going to measure this one. I'll get a better, here we are. 337. So that's, I'm not sure if you saw that or not. Let me move it up again. I'll measure it again. 337 is what I got, but I'll do it again. 345. So it's actually within spec, but for a 330 microfarad capacitor. This is actually a 330 microfarad capacitor. It's not a 470. How about the John Fu over here, the 470 microfarad, at least that's what it says. Let's measure it. It says 470, it comes in at 351, so this, again, this is a 330 microfarad capacitor, not a 470. How about one of the, let's see, there's one over here, it looks like a Saturn. It's a Yang Chun, yeah we are, not there, looks kind of like a Saturn. Yeah, old deer power supplies were infamous for these things. Let's see what it comes in at. $331. So again, it's a I'd say it's a falsely labeled 330 microfarad capacitor. How about this phi? Let's do it again. We just haven't measured it on video yet, but it may come out of range. I don't know. Let's see. 955. So I thought these measured in between 1,000 and 1,200, but this one's coming in at about 950. I'm gonna say that's a 1,000 microfarad, not a 1,200. Okay, how about the solid red? I don't think I got that one yet. $311. So it's actually a little bit below 330. Again, all the caps in this pile that are rated for 470 are coming in at 330 microfarads. Now I got one here, this MK, or this MK, that's that has a stated rating of 330 microfarads. You can probably guess what this one's going to be if you know your capacitors. And what do you know? It comes in within a range of 220 microfarads. So, yeah, the cheap end power supplies, not only do the cheap end units tend to skimp on things like EMI filtering, let alone having a extremely blown out of proportion nameplate rating. You know, these things that can barely do, let's say, 200 watts out of the box, they'll rate these things for 400, 500, sometimes 600 watts. If you're willing to do some soldering work on them, I should say, if you're willing to harvest parts out of scrap power supplies like the Best Tech 25012Es, get you some bridge rectifiers and EMI filtering parts and get you some better caps and stuff like that. I mean, you can make them into somewhat decent 200 to 250 watt units. Okay, so got the power supply pulled out of the IEPC. Let's go ahead and open it up. And first and foremost, I want to mention that this unit has only been unplugged for probably not even an hour. You want to use caution here, because sometimes the big caps can still hold a charge, but they generally do have bleeder resistors in parallel with them to drain them down. So, bridge rectifier is right there. This unit originally didn't have a bridge rectifier. I think I already mentioned about that. No, we're fine. It's totally drained down. Yeah, it had like 0.3 on there. So, this unit, as I've mentioned, it's had quite a bit of stuff done to it. different case. It's had, of course, better EMI filtering. Now I should say these caps over here, actually, I do think are original to it. It did have these, you can see right there, there's two blue caps right there. I think those were original to it. I added these two coils, this X cap, changed out the 4 diodes for the bridge, added this fan controller over here. I have a different power supply. So yeah, it's definitely gotten some attention, to say the least. So what I'm going to do is I'm going to change out those 2 primary caps. Okay, so before I put the replacement caps in, let's go and get you a look at the circuit board with the caps out. And these are the bleeder resistors right there. Those are, those are there to bleed down the capacitors, the primary capacitors, when power is unplugged from the unit. That way, this thing does not hold a lethal voltage after it's set for just a little bit after being unplugged from mains power. So you can see right here, we got our negative stripes right there. That's negative, and that's negative. So before I install these new caps, I'm going to look and see if I have a couple of MOVs I can stick in here, because you can see V1 or VZ1 and VZ2. Those are spots for MOVs or surge protection. That's another thing these units tend to not have, is MOVs installed. Okay, so we got 2 MOVs here, and these do appear to be matched. I think it's very important that we match these. And you'll notice how they're wrapped up in heat shrink. The reason why they wrap them in heat shrink, or at least most varistors or MOVs are wrapped up in heat shrink, is let's say you get a power surge. What these do is these have a preset clamping voltage, which is there's a little bit of headroom above the typical voltage that's in this area. But let's say if the voltage goes above that, these will clamp and send that excess surge to ground. They sacrifice themselves so they can literally blow up. So they put the heat shrink on there to try to help prevent the explosions from really causing utter damage. Because, I mean, what can happen? These can blow, but then the power supply could still continue to function. It wouldn't have surge protection anymore. So we'll go ahead and stick these in right there and there. And these, if I hadn't mentioned, were harvested out of a power supply of this same style. So pretty certain that their clamping voltages are the same. So I'm going to be back porch testing this thing afterwards. So if it blows up, it'll blow up outside. Yeah. I'll go ahead and insert these in there. Get the little legs lined up, and it doesn't matter what direction they go in. And see, what I gotta do is I gotta go under the PCB and melt the solder to let these legs get down where they need to be. Okay, so the MOVs are installed. They're not actually permanently soldered in just yet. I gotta add some solder to them to make sure they're actually in there good. They're still kind of loose in the holes right now. But I'm going to go ahead and install the replacement capacitors. So get these lined up, and I may have to tin the leads a little bit to get them cleaned up. Get this old glue off of here. Okay, so I had to find a different set of caps because the holes for the leads are just a tad bit too small for these caps here. So I'm using these other Chemicon caps. and they should go right in. I may have to spread the legs out just a tad bit. I mean, if I really want to, I could drill out those holes and make them a little bigger. But this will also work right here, so. And again, just kind of make sure we're inserting them the correct way. Okay. So now we'll go ahead and secure them into place, and also secure those varistors into place. Okay, before I put this thing back together, make sure I don't have any loose solder inside this case. I'll just double check everything real quick here. I know you can't really see what I'm doing, but I'm just looking everything over, making sure the caps are installed the right direction, all that good stuff. Making sure, of course, the MOVs are seated and they're good. Okay, so we've beefed up the primary caps in this unit, and we've also given it surge protection. Just double check the bottom of the board real quick. I tell you what, the soldering job when it's thing from the factory was definitely not the greatest. We're going to drop this back in. Okay, so I got actual 470 microfarad capacitors installed in this power supply, and it works great. It also takes a little bit longer for it to discharge whenever you switch off the power. I guess we could consider that the hold up time, and generally that's a lot better for a unit like this because let's say if you have a dip in your voltage or what have you, it puts a lot less strain on the main switchers in the event that something like that happens. So here's some footage of me testing the hold up time after switching off power to the system while it's shut off and standby. Okay, so here are the capacitors out of that unit, and I've also got two more just like them that I pulled out of a different unit at the same time. They're the same capacitors, the full tech 470 microfarads, which are really 330 microfarad caps. And I take an fair time for an opportunity to measure them out. So here's our meter, and what we'll do is, of course, we'll just see what these are doing. Yep, 330. 338, that's a 330 microfarad capacitor. .309, 310. The ESR in this one might be a little higher. So 312 in that one. Ah. .320. .308, 312, 314. So yeah, again, I'll grab a different capacitor here. Let's grab a Capzon 470 microfarad, which is 470 is what I end up putting in the unit, as I would consider that unit good for 250 watts. Definitely not the 480 watts the original label rated it for, but so yeah, check this out. .443, 466, 480. So 490 is what this one here is doing, and it's rated for 470. So I got my little scale here, and another thing I should note is, these capacitors here, the ones that all measured, the ones that were labeled for 470, it measured out to 330, and that one 330 that measured out to 220. One thing you'll notice about them is they're much lighter. So here's our 470 microfarad Capzon. It weighs in at about 18.3 grams. Here's the full tech. It only comes in about 15.2, so it weighs a bit less. So let's weigh all of these. About 15.1. That could explain why the capacitance is varying a little bit. 15.2. That one comes in at 17. This Capzon 18.2. So the Capzon, which meets its rating, is definitely a little heavier than the fakes over here. So these capacitors here, I mean, if you have an application where you're looking for a 330 microfarad capacitor, I mean, I'd say they'll work okay for that. But it just seems like, these things, they're all one rating below their capacitance is actually the equivalent of one rating below the stated value. Like, for example, here's this MK. Let's weigh it. 17.5, so it's similar. I don't know if I have any actual 330 microfarad caps in here. I don't think I do. Otherwise, we could weigh one. But, so yeah. It's just, like I say, for example, these Phi capacitors, they're pretty bulky. And I gotta restart this thing, zero it out. See, it comes in at 34 grams. 34 just about. So yeah, these are actually a little bit better quality, even though, like I say, like I think we've measured previously, these state they're 1200 microfarads, but they all seem to measure about 1000. So yeah, it just comes to show that the cheap power supplies that have, of course, the capacitors that in some cases or in many cases are not enough, the ratings are not enough to meet the of course stated outputs. The caps they use don't even actually meet the ratings they say they meet. So yeah, something to keep in mind if you're scrapping parts out of these cheap end power supplies. The capacitors, don't exactly trust their rating, because it seems that with these capacitors, they all seem to measure in at like one step below their actual stated rating. So anyways, hope y'all enjoyed this video. Thanks for watching. Well everybody, that wraps it up for this video, and I hope you enjoyed it. If you did, please like the video. Also, don't forget to subscribe to the computer channel, and be sure to tick that bell so you'll get notified when new videos are posted. Also, don't forget I have a whole lot of other interesting videos here on the channel to check out. And also, in addition, I have a second channel, CubeCompMTDX, where I have all sorts of other videos not exactly related to technology. Links to the channels are available at the end of this video. Again, I thank you for your support and thanks for watching this video.